When the New Horizons spacecraft zoomed past Pluto in 2015, it snapped photos of what appeared to be two massive ice volcanoes. Key points: NASA's New Horizons probe flew past Pluto in 2015. NASA's New Horizons probe flew past Pluto in 2015. It sent back images of what looked like two giant ice volcanoes. New analyses suggest the volcanoes are made of smaller upwellings of ice instead. Now, it seems these mega icy features are not two individual volcanoes, but instead were created when several smaller upwellings of ice joined up. And despite not being the singular, mountain-like volcanoes some scientists originally believed, they are still unlike anything so far seen in our solar system. Southwest Research Institute planetary scientist Kelsey Singer and her New Horizons colleagues came to this conclusion after analyzing images and topographic maps of the region. Unfortunately, there was not a single aha moment, Dr. Singer said of the study, which was Nature Communications Today. It was more like a long slog for a couple of years, asking what shape are these features, and how could it all work. New Horizons is the first and only spacecraft to whiz past the dwarf planet. It sent back images and data that transformed Pluto from a round smudge seen through a telescope to an enchanting rocky and icy world, dominated by a vast heart-shaped ice sheet. Just south of that ice sheet, there looked to be two gigantic volcanoes. One, called Wright Mons after the Wright brothers, was about 150 kilometers wide and 4 kilometers high. Its volume is around the same as Hawaii's Mauna Kea, one of Earth's largest volcanoes. New Horizons snapped this shot of Wright Mons on the 14th of July 2015 from a distance of 48,000 kilometers. Just to the south of Wright Mons was another, larger volcano-looking feature, this one around 7 kilometers tall at its highest point. It was dubbed Picard Mons, after the 20th century physicist and balloonist Auguste Picard. And on the face of it, they looked a lot like an icy version of the typical cratered volcanoes we have at home, said Helen Maynard Casely, a planetary scientist at ANSTO, who was not involved in the study. You can totally forgive them for thinking that. When you look at them, they are a round feature with a hole in the middle. They look a lot like the cratered volcanoes that we have on Earth. But as Dr. Singer and her crew analyzed more images, they realized there was more to the giant volcanoes than meets the eye. Telltale mega volcano signs missing. Picture a volcano. What comes to mind probably looks like a mountain with a bowl-shaped crater at the top, which is formed when hot rock collapses back into the magma chamber below. But look closer at the pair of Plutonian volcanoes, and that doesn't seem to be the case. A 3D topographic map of Wright Mons and Picard Mons. Blue indicates lower terrain and brown is higher, green is in between. Topographic maps showed the bottom of the craters in Wright Mons and Picard Mons were at the same level as the terrain surrounding the raised rim. The inside walls of the bowls were lumpy like the rest of the landscape, and like the telltale scars produced when a volcanic crater is formed, Dr. Singer said. And when we started looking closer at Wright Mons and Picard Mons, we realized that they were also smoothly connected to other large structures in the area. So instead of each being a big single volcano, they were more likely built by a different type of volcanism. Mushy ice burbled up from beneath Pluto's crust and made a bunch of smaller domes on the surface that happened to join up into rings. The texture of this icy mix was probably something like a frozen margarita or slushy, with ice crystals mixed with liquid, or perhaps more on the solid side like glacier ice, Dr. Singer said. When this all went down is still unclear, but it was likely fairly recently, given the relative smoothness of the surface, perhaps even in the past couple of million years. And we have lots of evidence that this wasn't just one big volcanic event. Instead, we think it's episodic, and at this point, we have no way of knowing if it could occur again in the future, Dr. Singer said, adding that this icy volcanism could well be going on today. Icy volcanism elsewhere. While Wright Mons and Picard Mons' origin story may not be what planetary scientists first thought, they are still unlike anything we've yet seen in the entire solar system, according to Erika Rader, a planetary scientist and volcanologist at the University of Idaho. Other icy worlds that exhibit volcanic action include Enceladus and Europa, moons that orbit Saturn and Jupiter respectively, but these tend to shoot plumes of water into their atmosphere, rather than ooze hefty ice domes. Still, it's possible to draw on what we know about volcanic activity on Earth and apply that to Pluto. Certain aspects of ice are very similar to silicate rock or melt, Dr. Rader said. The two materials behave in the same way. While it may seem far-fetched to think red-hot liquid rock and ice can act similarly, remember that Pluto is on the outer regions of the solar system, so is very cold, Dr. Maynard Casely said. A warm day on Pluto is 60 Kelvin, minus 213 Celsius. Dig under the icy crust, and it's warm enough to harbor a subsurface slushy ocean, thanks to heat generated by, for instance, the radioactive decay of elements in rocks. So the ice comprising Wright Mons and Piccard Mons is thought to be mostly water ice, mixed with a few antifreeze compounds, which allow it to flow a bit before freezing at those frigid surface conditions. Neptune and its moon Triton, shot by the Voyager 2 spacecraft when it flew by in 1989. And clues to how these frozen volcanic cocktails behave could come from the icy Neptunian moon Triton, Dr. Maynard Casely said. Triton, we're now beginning to think, is a lot like Pluto. Not only is Triton the same size, but planetary scientists think it was once a free agent like Pluto too, cruising around the solar system until it was captured by Neptune and slung into its orbit. It also has vast ice sheets and mounds created by icy volcanic flows. But while a mission to Triton was proposed by NASA in 2020, it was rejected last year.